Eric, you were speaking at the conference this year. Can you briefly summarize what you were talking about?
Yes, trying to establish guidelines, design guidelines for a safe, high-power, high-performing battery pack that we can share with the rest of the users in the community.
Thermal management is one of the key technologies unlocking high-performance applications for batteries. Are there any promising technologies in this field that are coming down the line in the next few years? And if so, what are they?
Yes, there is. One of the most promising technologies is a plastic current collector that's metallized that'll act as a fuse. In case of an internal short, it will isolate the active material involved in the short from the rest of the cell. It's a new technology that's very new, and is showing promise early on in our calorimetric test and in our thermal runaway test to be able to handle some nail penetration events and produce a lot less thermal response on that. So that's one technology that could prevent thermal runaway from happening. As far as the other technologies that assume that thermal runaway occurs and then reduces the severity of that event, there's all sorts of phase change materials, and shields, and some very advanced thermal components that are able to manage and quickly get the heat away from the adjacent cells and into a heat sink. One of the heat sink technologies we're working on is an oscillating heat pipe that has a working fluid inside through some microchannels that's able to shunt the heat away from a cell and get it down to the housing of the battery away from the adjacent cells, which is very important in a thermal runaway type of situation, but is also very useful for having uniform temperature gradients or minimizing temperature gradients within a battery pack, which is very important for cycle life and for the life of the battery.